Today, we're going to talk about microplastics. That's right, I'm back, and I'm here to talk about plastic again.
So, in layman's terms, is it possible for you to explain what is a microplastic? Because some of my viewers aren't necessarily into science.
Yeah. So I'm based in America. I'm in North Carolina at Duke University.
Hello, everyone. Welcome back to my YouTube channel. Thank you so much for stopping by. In today's video, I have the wonderful Imari Walker, all the way from the United States of America. She is an analytical chemist, an environmental engineer, and an oceanographer, and her special expertise is researching into microplastics. So, Imari, please could you tell us who you are, what you do, and where you are based?
Yeah. Hi, everyone. My name is Imari. I am, quite a few hats I wear, but most of what I do is chemistry. And I am at Duke University doing a PhD in environmental engineering. So I study plastic in our environment and how chemicals that are used to make plastic can end up being released into our water that we drink or that organisms live in, and how those things can be potentially toxic to us and our surrounding environment. Yeah. So I'm based in America. I'm in North Carolina at Duke University.
Awesome. So why did you choose to pursue a career in, microplastics and chemistry?
Yeah. So I started off as a marine scientist for my first degree as a bachelor's in science. And when I was studying oceanography, I was really curious about pollution, about water quality. It was especially started on my trip when I went to Tahiti to study abroad. And I started to notice that a lot of my colleagues were getting sick from the water. And so those were questions that I thought about, like just people who have access to clean water and how those can be problems. And then the fact that they have to drink bottled water if that's not an option for them. And so is that just another possible entrance for other harmful chemicals or entities to end up in their lives? So that kind of was one of the first starting points. And then I took a class in chemistry, and they were talking about the fact that there were, all these sea turtles interacting with the plastic in the great garbage patch or the multiple patches that there are around the world, and how this plastic can act like a sponge, not just for other chemicals that were already present in the ocean that had been banned for decades. Those things can just attach itself to the plastic and travel around the world for thousands of years because plastic doesn't degrade, fully. And so that really just kind of sparked the idea for me of like, okay, I know I'm going to do chemistry. I know I'm going to study the transport of chemicals, but like, I know I want to do plastic with this.
Awesome. So you were inspired by your trip to Haiti and its impact on sort of the animals and its lack of degradability, which is very interesting. I also studied chemistry as well. I don't know if you knew that, but I haven't really gone down that route necessarily. But yeah, it's really good to see that you're using science to hopefully make an impact into the world. So in layman's terms, is it possible for you to explain what is a microplastic? Because some of my viewers aren't necessarily into science. And also, what are the important facts we should know about microplastics?
Yeah, so a microplastic is just a small piece of plastic. Usually scientists say when they call something a microplastic, it's smaller than the pin on a bulletin board, so or the top of a pencil. Anything smaller than that is a microplastic, and they can get down to smaller than the diameter of like a hair, smaller than that length, and they're everywhere. They can come from our water bottles. They can come from everything that we touch usually has some form of plastic on it, whether we're switching our lights on to grabbing our phones with the plastic casing. There's so many different types of plastic, and they will all eventually start degrading into smaller pieces of plastic because they're exposed to air, they're exposed to light, to water, just things that will age and crack a plastic. And so when you see a plastic turn white or yellow and discolored and cracking, you're seeing the process of microplastics forming and being released into our environment.
Awesome. And so what are the facts that we should know about microplastics, other than the stuff you've just said?
So I also have a YouTube channel for under Imari Walker, and I did release a video on the 10 facts you need to know about microplastics. So some of the interesting ones are microplastics can be tasty. Depending on what organism you are, they are attracted to the flavor of plastic. Some great examples you can see at home is if you have a cat, they tend to like to lick plastic or chew on it. Even children, small children, like to chew on toys. And because there are chemicals present inside of those plastics that taste good to them, but doesn't necessarily mean that it's good for them. So, really just to be careful of that. And then the fact that there are thousands of different kinds of chemicals that are placed in these plastics, and a very small percentage of them are actually looked at for if they can cause cancer, cause lower sperm count, to just any kinds of reproductive, mutagenic, carcinogenic problems. They have not fully done an understanding characterization of these chemicals. So those are a few, and they're everywhere. They're in our water, they're in our air. You can't go home and miss them.
It's interesting. Guys, make sure you check out her YouTube channel, because on your YouTube channel, you talk about water bottle is cancelled. Usually we cancel people, not things. So I'd love for you to talk about why water bottles are cancelled, and also what we can do to replace them, a more environmentally sustainable way of drinking water, which isn't using a plastic bottle.
Yeah. So there's a few reasons usually water bottles will be canceled. That's only if you live in an area where you have good access to clean drinking water, which is a lot of the world that we live in, is that there is, your Brita water filters. You can go to your state or, your country's website to see what is the water quality. There's usually an annual report that you can learn about and see, okay, this is what the limits are for lead, and this is how much they've recorded for almost anything that you would be very curious and worried about. So there are pretty good characterizations of water reports. And so that's what I explained in that video of how to do that and how to look that up. And then also just the idea that you're paying 4,000 times more for plastic water bottles. You're basically paying for the plastic, because the water is essentially the same as what comes out of your faucet. There's no difference, other than the fact that they're not testing it. They don't have the same regulations as water that comes out of your faucet. So really think a little bit more about it. Think about the fact that it's being thrown into landfills, and a lot of those water bottles are not actually being recycled like they say they are. So yeah, definitely check out that video. There's a lot more tidbits to know, and cancel water bottles if you can.
Awesome. I'd like to know, where do you see your career going, or where do you want to be? Where do you see yourself in 5 years, or what other areas are you looking to explore?
Right now, I'm in my 5th year of my PhD, so I'm trying to finish my doctorate this year in 2021. And then after that, I think what I'll do is a little bit more research in studying plastics and in the release of these chemicals, followed by getting a little bit more into the policy, because I think it's important for us to start acting now and putting together plans to start addressing our problems with plastic, with our problems with recycling, our problems with waste management. And so I think there's no better than a scientist that has seen it and worked with it to try and address it with a policy angle. So that's definitely one of the areas that I'm going to try and veer into a little bit along with the research.
Awesome. So thank you very much for explaining sort of what microplastics are, and why we should avoid using water bottles. I guess I'm going to have to invest in something a little bit more sustainable, because I would honestly say that I'm a water bottle warrior. And it would be nice to see women in STEM, women in science and policies, and to helping improve environmental changes. So we're going to sort of fast track a little bit, because I think we kind of missed you talking through your educational journey from high school, like what you studied, to university, to now doing your PhD. If you could talk a little bit more about, here we have what we call, after high school, we have 2 years where we focus on like 4 subjects A levels, or 3 subjects A levels, and then we go to university, and then we do our graduate. So could you tell us a little bit about what like things you mainly studied at high school, and then afterwards what happened there, if that makes sense? Yeah.
Yeah. So when I was in high school, I think I knew I wanted to be a scientist of some kind. I think I was gearing a little bit more towards medicine. So I was taking a lot of pre-medicine like electives and courses. And then when I got to university to my undergrad degree, it was mostly a focus on oceanography. So that was a 5 years for me, just taking classes in chemistry and biology, in earth science. So just understanding how the geology of our Earth, to even just like how Earth actually formed, how planetary science works. So those were a lot of the main classes that I was taking, and then I was also doing research. So I spent 3 or 4 years, mostly in the summers, going to different universities and doing research projects around climate change. So I was trying to understand where does carbon go in our ocean? How do I as a researcher help impact that body of knowledge? And then also, how old is our Earth, and how can we predict the temperature of the Earth hundreds of thousands of years ago using chemistry, using biology as an example? And so I had a variety of chemistry and geochemistry experiences while I was also taking classes. And then as I knew I was switching into engineering for my graduate program, I started taking some of the coding classes that I needed. I started taking more of the math, heavy emphasis on the multivariable calculus, the linear algebra, and just getting that environmental engineering experience for coursework as well before I started graduate school. So that was something, along with doing an internship at Intel as an environmental engineer before I started.
Awesome. I want to touch on the environmental engineering and you doing your coding classes, because I like to see how science and technology are working together. So how did your coding skills and your technical skills help you in your career, or how are they useful within the field of environmental chemistry?
Yeah, I think it's probably one of my most valued skills, to know how to code. Specifically, when I was in my first degree with university, I was mostly learning MATLAB. Yeah. And a little bit of R, but MATLAB was mostly because of the engineering, and in the university that I was at, really had an emphasis on using mathematical skills to model how earthquakes happen, or the movement of a state. Like if California fell off the surface, can you model that? To when I started my environmental engineering degree, it's more like, can you understand the statistical analysis of your results? Can you handle big data and try and interpret that better? So really what they call chemi-informatics is what I do a lot more of. And then along with just when I have to make presentations or representative figures, I do a lot more work in R to actually code the figure. So I've thrown Excel out of the window for most of my stuff, other than to put it in a table and then put it into R to code and analyze for data purposes. So quite a lot of coding has been placed in my hands for my PhD, at least in environmental engineering.
Awesome. Thank you for emphasizing the importance of technology within science and how it's being used to, help with research work. So that's really great to see. The last questions that I had for you is, what are some of the challenges you have faced doing your research?
Yeah. There's always technical challenges. Pardon me. I think the easiest thing that I can think of off the top of my head is just motivation to continue. I think that's something that can resonate for a lot of people, no matter what stage you're in, because there's always some form of a challenge, whether it's just a very difficult course, or you get stuck in research and you don't know how to continue, and you feel like you don't have the right support to keep going. And so the motivation to keep pushing through has definitely been something that I have encountered at all levels. And sometimes it just forces me to take a little bit of time to think about why I'm doing what I'm doing, and why this is important, and trying to contextualize that, I care about people's water quality. I care that, that this class is difficult, and, I don't enjoy it as much, but I know that it's going to give me the tools that I need to be a better engineer, to be a better scientist. And so, and that it's momentary. The discomfort, the feeling like you're not able to go a little bit further than you can. Just reminding myself that I just have to keep pushing forward because of those reasons, and to have to just kind of ground myself to keep going. And so I think that's definitely like just the biggest challenge overall is motivation.
Awesome. Thank you so much. The key points I got from that is basically you've got to enjoy what you do, because I guess it's sort of hard to be motivated after a certain time. If you don't have motivation or you're not interested in it, then you can't really sort of go through. So it's very good to hear that, it's something that you enjoy, and, because you like it, you're trying to be motivated, even though sometimes can be a bit down in the dumps doing the work that you're doing. So yeah, thank you so much. That's all from me. That's all the questions that I have currently. Again, I'd like to say thank you so much, Imari, for agreeing to be on my YouTube channel. Guys, please check out her YouTube channel. I'm going to post links below. I'll also add some videos and slides, maybe at the intro and at the end. And yeah, if you'd like to see more videos of me interviewing fantastic, excellent and amazing women in the field of science, then please make sure you like, subscribe, share and comment, and I'll be back with another video. Bye.
See you. Thank you.